So welcome back. We stopped at looking that as a low risk anomaly in our returns, and I promised you to quantify that the R square of such a CAPM regression is roughly twice as large as if you regress it on full risk. Let's just see what we can learn from that. Basically, the punchline here is that the CAPM fails in EU50 data. Keep in mind, it depends a lot on how we measure things. And here we just use backward-looking data and a backward-looking regression to back out the beta. But let's just do it. Yeah, it's an exercise for you. We've done it in a previous video with total risk. So what's my X variable? It's the investment opportunity data frame, and there I take the beta. And I'm also going to add a constant. So I'd use the stats models, which I uploaded a package in the previous video. If you haven't seen that video, just go for that video. Otherwise, just Google for the stats models.rp. That's what I imported. So I take the stats model dot add constant and add that to X. What is my Y variable? It's the inf op mean. And what do we want to do? We want to run a GLS regression. Yeah? So GLS mu on beta. And that shall be my stats models GLS Y comma X. All right. That should run and then give me the fit mu beta. And that is just the GLS mu beta dot fit function. And as it's just what we've already done, let's just print the results of the regression table. Mu beta dot summary. Would you mind doing that? Not at all. Thanks. All right. So you see, that's a CAPM regression with our just 40 observations. It's a cross-sectional regression because we regress the average returns of all the 43 firms onto. Are you kidding me? That is not a CAPM regression. CAPM fails. Of course it is. I regress on the beta. Of course it's a CAPM regression. I regress. No, wait a minute. It's not a CAPM regression. In the CAPM regression, you would regress excess returns, or let's say the average return, onto the market return, and then you get the betas. That we don't do. We computed the betas explicitly. Here we do something different. We regress the mean returns onto the betas. That is more like in the Farmer-Macbeth two-step approach regression, the second step to compute the market price of risk. That's what we do. So why do we do it? Because we just want to fit a line through here. And we know the slope of that line would be how much return do you get on average for a change in beta. So it's the market price for beta risk. That's what we do here. And you see the regression has a 20% R square. It is previously in the video sequence, we also regressed it on the standard deviation, so total risk, or the square root of total risk, and the R square was like 13%, 11 to 13. So that's good, right? Because total risk shouldn't matter too much for a portfolio manager as these guys diversify, hold portfolios. If anything, it's about the systematic part of the risk that you cannot diversify away. And we see in the data, there's evidence for that. That mean returns, here a fifth of the cross-sectional variation in mean returns can be explained by the beta, but 80% cannot. All right, but we just have a very short cross-section. So what do we get? We have the constant here. So there's an alpha which we cannot explain. Of course, there's 80% unexplained. And we have that the slope coefficient on the beta, which would be the expected market premium, is negative. It's negative. All right. So let's just have a plot, and again, let's just save some time. So we do some hopefully smart copy pasting. Here, I just want to copy from that what we've already done. Just need to make sure I copy in the right ingredients. We make a scatter plot in op we haven't changed here. So I want to plot beta. I want to annotate the beta mean coordinates, and PLT, I want the beta on the x-axis and its fit mu beta. So you see, naming variables well is of use. Give me the prediction and now show the graph. Okay, right, so you see. ING, boom, perfectly on that line. Siemens, Daimler, 1/n portfolio, SIP, they're just all Volkswagen. I mean, the German firms, Germany is always well ordered, right? They are kind of ordering up on that line. Telekom, Millennium loser, it's an outlier, so to speak. BASF, BMW, they're not too far off, but they're off. Adidas, right? So Adidas, according to the CAPM, just tells you that Adidas, but it's now theory driven. My argument, Adidas has a positive alpha of something like this 16% versus 8. So it has an 8% alpha, which means that it overperformed relative to its amount of systematic risk. So the return it earned was too large. Okay. Okay, great. So I just stopped the video and look at the graph myself to think about what to do next.